This lesson is part 1 of section 9.3. We're going to be working with the sum to product formulas that we proved in our prove it notes in part 8. So I know that at this point you probably don't want to do this, but you need to go back and watch part 8 of your prove it notes. So I'm demanding that you stop this video right now if you haven't already watched the prove it notes for part 8, because otherwise these formulas look, one, kind of meaningless because they're just a mumble jumbo of sines and cosines and you have no idea where these formulas have been derived from or why they look the way they do. So please, I'm begging you, go back and watch part 8 of your prove it notes. So anyhow, if you've already done that, awesome. You're doing what you're supposed to be doing, and your main objective for today is to actually apply them. So we're going to apply our sum to product and product to sum formulas today so that we can rewrite expressions. So I'm working under the assumption here that you are familiar with how we derived our formulas, and also you're familiar with these formulas a little bit, so I can kind of assume that you have them quasi-memorized, okay? So I'm going to go through these and basically give you some tips on how you can identify whether or not you're using, the sum of two signs, the difference of the signs, the sum of cosines, or the difference of cosines. Because it could be very intimidating to try to do this since they all look sort of similar to each other. Now, I talk about this in the end of the prove it notes, but there is a special note, and in terms of this a and b here, if a is greater than b, then we know that a plus b, the sum of a plus b and a minus b, that would have to equal 2a. We also know that the difference of a plus b and a minus b would give us 2b. Now, this doesn't look like anything all that mind-blowing. Freshmen in Algebra 1 could even do something like this because a plus a gives me 2ab, and the negative b here cancel and leaves me with 2a. So this doesn't really look like much here, but because we're allowing you guys to use just these 4 formulas, it basically minimizes the number of formulas that you need to memorize. I think your textbook uses 8 different formulas. Here we're only giving you 4 in order to go from a sum to a product or a product to sum. So they've got 4 just for the sum to product and another 4 just for product to sum, whereas here we kind of summarized them in just 4 main formulas. So this little note here is going to allow you to go from either a sum to a product or from a product to a sum. So we're going to hit on this and stress this a lot as you apply these formulas. So let's get started here with number 1. We're going to rewrite a product, the sine of 4 theta times the sine of 3 theta, as a sum or a difference. So just looking at this, I realize that I've got 2 sines next to each other, right? This is a product of 2 sines. That only comes from taking the difference of cosine of a plus b and the cosine of a minus b. So here, right away, that's how I would identify that I want to take the difference and rewrite this as a difference of cosines, okay? So let's get some more room here. So I'm going to basically follow this model right here. So sine 4 theta, sine 3 theta can be rewritten, okay, as the difference of the cosine of a plus b and the cosine of a minus b. Okay? Now in this case, it's really easy to identify what a and b are, right? Because this is in terms, the product here is in terms of a and b. So this is my a value, this is my b value, and right now I'm just missing that whole -2 thing. So I really want to make sure right away actually that I would divide out that -2. So I'm going to call this -1/2 times the cosine of a plus b and minus a minus b, or minus the cosine of a minus b. Okay, so now at this point it really is just about substitution here. So it's not too tricky here. I just take the cosine of 4 theta and 3 theta, add those together. So I get, sorry, I don't want to skip a step for you since we're just doing this for the first time. So it's going to be 4 theta plus 3 theta. And then we're going to take the difference here of the other cosine function, which is going to be 4 theta minus 3 theta. And of course I know that you can follow formulas and stuff, but the main idea here is that you see 2 sines, and that only comes, like I said, that product only comes from taking the difference of the 2 cosines. So now if I simplify here, I end up with the cosine of 7 theta and the cosine of theta here inside the parentheses. Make sure you don't distribute. I've seen people try to simplify that and write that as the cosine of -7/2 theta. That's totally not right, so please don't do that. This is the product of sine 4 theta, sine 3 theta, written as a difference, okay? So that's number 1. So that one's a pretty, easy problem, I think. It's not until you start getting into rewriting a sum as a product that's when it gets a little bit trickier, and that's when we'll really need to use this little note. So problem 2 here is a very similar problem to number 1, where we're taking a product, the cosine of 3 theta times the cosine of 5 theta, and we're rewriting that as either a sum or a difference. Now, I see cosine times cosine here, and I know that that is the first term when you do a cosine addition formula, right? So if you don't know what I'm talking about, that means you didn't go back and watch your Prove It notes, so go back and watch your Prove It notes, please. Okay, so that you understand what's going on. But basically, I already know that I should be using cosine of a plus b plus the cosine of a minus b to rewrite this particular product. And again, that's 2 times the cosine of a times the cosine of b. So I want to kind of make it look more like this by dividing out that 2 right away, calling that 1/2 times the cosine of a plus b plus the cosine of a minus b. So that's my general setup for right now. Okay, now another thing that we want to talk about is the fact that we like to have a greater than b, right? That's our special note, is to make a greater than b. So in this case, it probably would be better if I just wrote that as the cosine of 5 theta times the cosine of 3 theta. That's no big deal, right? The multiplication is commutative, so I can do that. And that actually will let me then have positive values inside here. Okay, it's not that you can't have a negative value, but then you'll have to consider, for example here, if I were to keep this value here, the a, and this value, the b, then I would be taking 3 theta minus 5 theta, and then dealing with the cosine of negative 2 theta. You'll have to realize that using your opposite angle addition, your opposite angle identity, that's really the cosine of 2 theta, which isn't hard, but I don't know, it's just one extra step. So really, this allows us to avoid dealing with any negative angle values, okay? All right, so anyhow, like I said, this is just an exercise in substitution at this point. So this is a pretty easy problem again, where we're going to take a and b here. So we have 1/2 times the cosine of 5 plus 3 theta gives me 8 theta, plus the cosine of 5 theta minus 3 theta is 2 theta. And that's really all there is to this particular product here, to rewrite that as a sum. Okay, now 3 is a little bit trickier actually, because this product, the cosine of 2 theta times the sine of 6 theta, could actually be rewritten as the sine of 6 theta times the cosine of 2 theta, which would completely change, if you're using a sum or a difference. So we know that, let's go back to the formulas up here. Okay, when I add 2 sines together, okay, I end up with the 2 first terms, the sine of a times the cosine of b, which gives me 2 of them, right? If I take the difference of the sine of a plus b and the sine of a minus b, then the first terms end up dropping out, leaving me with the cosine sine part, right, of our chant, sine, cosine, cosine, sine. So the second part is the cosine sine part. So the first terms drop out, the second terms remain, leaving me with this. So when you look at that problem, when you can rewrite sine and cosine and flip the order, how are you supposed to know which one it is? Well, that's why this whole note here of defining a larger than b is very important. So here, again, it's important that we know that a is larger than b. So I actually want to use this guy here, sine 6 theta cosine 2 theta. Now the sine cosine term is the first term of your angle addition for sine. So that means I'm using the first terms, which means I'm adding the sine of a plus b and the sine of a minus b. Okay, so that's the general formula that I want to be using right now. So then from here, after you establish which formula it is, again, it's really easy because you know your a and b values. So we've got sine of 6 theta as my a value is 6 theta and my b value is 2 theta. Okay, get rid of that 2 here, bring it over to the other side, and let's call that 1/2 times the sine of 6 theta plus 2 theta gives me 8 theta, plus the sine of 6 theta minus 2 theta gives me 4 theta. Okay, so that's kind of boring actually, I think, because those are pretty easy. It's not until you start getting into a problem like number 4 where it becomes a little bit trickier. So in 4, we're supposed to take a sum and rewrite it as a product. Now I guess it's nice that you don't have to guess at what you're using, because here you clearly see that we're taking the sum of 2 cosines. Well, so I know then that if I take the cosine of a plus b and the cosine of a minus b, I should end up with the first terms of each of those angle additions, right? Remember, when you take the cosine of a plus b, you should get cosine, cosine, clap, sine, sine. Okay, so if I take that and I basically get the first two terms of each of those, then I end up with 2 cosine b's. So 2 cosine A, cosine b's, because the second terms, the sines, those will drop out, right? Because you're canceling them out. Anyhow, now, in this case, it's harder, I think. Well, there's a little bit more work, I should say. It's not really hard, but there's a little bit more work here because this value, this 11 theta, is not A. This 3 theta here is not B. That's smushed together. A and B, the sum is 11 theta. A minus B, that difference is 3 theta. So here you actually have to solve for both A and B. And the way you're going to do that is by taking that note that we talked about before. If A is larger than B, then A plus B, that sum of A plus B and A minus B, that's going to equal 2A. And the sum of A, I'm sorry, the difference of A plus B and A minus B, that should equal 2B. Okay, so we have to apply those notes here in order to actually find our A and B values. Okay, so again, this is not A, and this is not B. Okay, so let's find what A and B are so that we can rewrite this here as a product. So what people get confused with is that they'll think, okay, I'm going to take 11 theta, and I'm going to add 3 theta. And then I'm going to add to that 11 theta minus 3 theta. And that should give me my 2A value. But that's not true. This is not A, and that's not B. The whole value, though, is your A plus B. Okay, so I take this entire thing, that is the whole expression for the A plus B. So really, I have 11 theta plus 3 theta. That should give me 2A. Again, 11 theta is the whole, why do I keep writing 10? 11 theta is the whole A plus B, and 3 theta is your whole A minus B value. Okay, so I get 14 theta equals 2A, which means A is equal to 7 theta. Now, to solve for B, I use, again, that same idea. This whole expression here is equal to 11 theta. So I have 11 theta minus 3 theta. That should give me 2B. So 8 theta equals 2B, and B will equal 4 theta. So the cosine of 11 theta plus the cosine of 3 theta can be rewritten as the product 2 times the cosine of 7 theta, this is my A value, times the cosine of my B value, 4 theta. That is actually how you take that sum and rewrite it as a product. So it's a little bit trickier because you're not just following a formula when you figure out which one to use. This one you actually have to do a little bit of solving in order to find your A and B values. All right, let's work on 5, which is a little similar again. So here we're going to rewrite a difference, the sine of 8 theta minus the sine of 2 theta as a product. So when we take a difference, that leaves us with the second two terms. Does that make sense? Leaves us with the second two terms. Leaves us with the second terms of the sines. So in a sine addition formula, you get sine, cosine, cosine, sine, right? The second term is the cosine sine term. So we're going to get 2 of those. So the sine of 8 theta minus the sine of 2 theta should be written as 2 times the cosine of A times the cosine of B. Now again, we need to figure out what A and B are. Don't take the note, which is A plus B plus A minus B equaling 2A. Don't do that and think 8 theta plus 2 theta plus 8 theta minus 2 theta and try to solve for A, because you're going to get that value, 8 theta. That's not what you're supposed to do here, okay? You're going to do it on your homework anyways, even though I'm telling you not to do it right now, and you're going to run into that mistake just once, and hopefully after you do it once, you'll realize, oh, I know what she's talking about now. But anyhow, so my A plus B value here is 8 theta. Okay, so 8 theta plus my A minus B value, which is 2 theta, that should equal 2A. So A would equal 5 theta. Now, my A plus B value minus my A minus B value should equal 2B, which means 8 theta minus 2 theta will equal 2B, so B is equal to 3 theta. So now I just make the substitution back into here, okay, once I have my A and B values. So the sine of 8 theta minus the sine of 2 theta should equal 2 times the cosine of 5 theta times the cosine of 3 theta. That is the difference written as a product. Okay, now in problem 6, it doesn't explicitly tell you that you want to change something from a product to a sum. It asks you instead to find the exact value of the cosine of 5/12 pi times the sine of pi over 12. Now, both of these numbers here, those are not values on our unit circle that we're familiar with. We don't know what the cosine of 5/12 pi is offhand, and we don't know what the sine of pi over 12 is. But if we can change this into either a sum or a difference, then we can actually evaluate using a plus b and a minus b, because if you look at this, if I take the sum of those two things, I end up with pi over 2. And if I take the difference here, I end up with 4/12 pi or pi over 3. So those are both values that I do know, the cosine and sine values for. So I'm going to change that into a sum or a difference. Now let's talk about how to figure out which one it is. Well, here I've got the cosine of, this is going to definitely be my a value. Okay, the reason why is because it's larger, right? And then that one will be my b value. So I have cosine sine. That comes from taking the difference of sine of a plus b and sine of a minus b. So it's the difference of the two, right? And that would give me 2 cosine a sine b. All right, so I, from here, can just make substitutions now that I've identified, which formula to use. So here it's pretty straightforward. Let's get rid of that 2, call that 1/2 times the sine of, in this case, let's just make the substitution right away. Let's do 5/12 pi here, and the sine of pi over 12. Okay, so we're going to add 5/12 pi and pi over 12. And then we will, gosh, I didn't leave myself any room here. Sorry, I'm going to have to erase. Then we will subtract the sine of 5 pi over 12 minus pi over 12. Okay. So we've talked about already that the sum of those two is pi over 2, right? 6/12 pi is pi over 2, minus the sine of 4/12 pi over 3. Okay, and that's going to equal this product. My hand is hurting from writing all of this. Okay, now let's go through and evaluate the left-hand side. So 1/2 times this quantity. Well, the sine of pi over 2, that's 1. And the sine of pi over 3, that is your high point, which means you have the highest sine value here, root 3 over 2. So we're taking 1/2 times 1 minus root 3 over 2. If you want to simplify this a little bit more, I guess you could just distribute. So you have 1/2 minus root 3 over 4, and you don't have to combine this, but you could, I guess, a little bit further. Your book might combine these. I think it does, and makes that one fraction. So 2, that's minus root 3, sorry. So 2 minus root 3 over 4 would be that exact value for this product here. Alright, last up, number 7 is very similar to number 6. We're supposed to evaluate the sine of 105 degrees times the sine of 15 degrees. Whoops, sorry about that. But these are not measures that we're familiar with, so we need to manipulate this somehow so that we can get values that we're comfortable with on our unit circle. Now, if you recognize the sine of 105 as the sum of 60 and 45, you can certainly do this problem using the addition formula there for sine, and then the sine of 15 degrees, you could use a half angle formula there. There's certainly no shame in doing it that way. It's just maybe not the most efficient way of doing it, and I'm trying to give you enough practice with all of your formulas so that you can recognize things and be a very efficient problem solver. So in this case, when I see the product here and I recognize the fact that if I add these two together, I get 120 degrees, and if I subtract them, I get 90 degrees, I can use one of those sum to product formulas. So I'm going to change this product here into either a sum or a difference, and because I see sine times sine, that means that I'm taking the difference of the cosines. So I have the cosine of a plus b minus the cosine of a minus b, which should give me negative 2 times the sine of a times the sine of b. So here I just, obviously make appropriate substitutions. So after I establish, which one it is, it's very straightforward after that. So I have negative 2 times the sine of 105 times the sine of 15 here. I need to get rid of that negative 2, so I'm just going to divide that out to the other side. So I have negative 1/2 times the cosine of a plus b is 120. and a minus b was 90 degrees, so the cosine of 90 degrees here. So let's evaluate now. So I have negative 1/2 times the cosine of 120. Now the cosine of 120 is going to be just past that 90 degree mark. So that's your high point. If I draw that unit circle, that's my high point here, which means then that my cosine value here is the shortest distance. So that's going to be 1/2. Okay. Now it's also in the second quadrant, which means the cosine here is negative. So it's negative 1/2, and the cosine of 90 way up here is just 0. Alright, so we're just evaluating then negative 1/2 times negative 1/2, which is positive 1/4. Now, if you're ever really unsure about this when you're working on your homework, obviously on your, your tests you won't be doing this with a calculator, but on your homework you can certainly check your answers. So go back and type in that original expression into your calculator. Make sure you're in the right mode. So in this case I'd be in degrees. If I type in the sine of 105 times the sine of 15 degrees, I should end up with 0.25 or 1/4 in my calculator. Okay? Okay, so that's the end of the lesson. Nice job. I want to take the time to actually say thank you too for all the hard work you guys have been putting into both the Prove It notes and all of this trig stuff. I know this is a lot of formulas. It's not necessarily easy, but as long as you have been keeping up with those Prove It notes and you've been practicing with them, and then you've been keeping up with all of these videos, I have the utmost confidence in you that you will smoke that Prove It test. So keep it up, and I will see you guys tomorrow in class.